Welcome to the stream. Yeah, so yesterday we worked a bit on these forms for creating the activities, and we'll continue with that effort today. I have to start up the project first because I didn't do this yet. So here we run the SvelteKit feed dev server and Firebase emulators. So close the hard disk. Oh. Cool. So we have this website. So we got the dope XD. Oh. This is better. The overhead camera. So we're working on this creating activities for teachers, and we made this dashboard, at least a sidebar, and we have searching for learning goals, and then we have this form, and you can we still need to preview it, so we can do that first. And at a certain point in time, we want to make the activity. But there's some complexity about how to store the information. So we'll just start this Pomodoro timer thingy. So we have 22 minutes to work on a task, and then we'll have a little break. That's how we do it. Yeah, and let's try to make like a little bit of an overview. I think that's a good start. So we have these work pages. This is the work page. And this is sort of the pull request page. We have a little bit of information. And then here you have the status, plus messages, plus history. So you have status change to needs approval, something like that. And user one commented about the activity plus learning goal. And then you see the teacher has changed the quiz with some differences. You see like the diff, all new. So this page is quite important, we think. So we have to think about this. Because we use this Firebase Firestore and it's NoSQL, so normally you would just link things and join tables. But in this case, it might not be the best way to reuse content. So this is one page we want to use, and the other one is the teacher dashboards. It will be sort of this YouTube list with status things. Oh, that will be related to this teacher user ID, and it will have these just some data tables, I guess. So it will not contain too much information. This is the dashboard. Teachers. And we show the activities here. Activities, some information about the activities, some data, some stats. I have one more page that is this status venture pages. So that's also sort of a list. And it is in this goal page. So it's this goal, and then there's these statuses in tabs. And based on the page, we have this published versus needs approval, in progress, and this needs work, and the trash can. So these are tabs, and if you click one, you get like these lists of activities. And then of course we have the teasers. So we have some sort of map or location, but at one point you get this page where we show the teasers for these activities. So we'll show like an image and the difficulty, and then we'll show like a few of them. This title, image, difficulty. These will be the activity teasers. There's quite a few places we use them already. And of course then we have the activity page. But that will be just the video, the quizzes. It's this activity page. With a nice video, interactive title, description, etc. So everything related to the activity. You just want to display it. Some battles, quizzes. Yeah, I think maybe we should also include like battles here, because that's part of the goal at the moment. So yeah, why I want to list these pages, because we have to think how to store an activity. We used to call them adventures, but they're called activities now again. And what pages should we really support well? So, for example, this teacher dashboard contains some information, but not too much. It only contains like a very detailed, like a title, description, and then some stats. And this work page will contain like all the history, revisions. This is also more like a list. And this is just a teaser. And this is like the full activity. But this doesn't need to have the revisions, for example, like the changes, the history. So every page has different specific information needed to display the activity. Activities. That's sort of one thing we can notice by using this. So this one needs maybe some stats. And only activities that the teacher created. This page is only activities with a specific status attached to a learning goal, and only some fields, maybe some stats as well. I don't know if we can get some specific stats, but they can be different. Then this work page, it has like all the status updates, revision diffs. Yeah, I think most information for a learning goal. This is sort of a bit of a strange thing, and this is activities returned by the engagement deep learning algorithm. It needs to have like a title, teasers, difficulty, image, just basic teaser stuff. In this page we'll have like all content, just activity, content, video, quizzes, title, description. Why do I list these things? What's the point of having this overview? Because we sort of have to optimize on read. That's an important part of Firestore and Firebase and NoSQL in general. That's, I think, the optimize on read. That's an important guideline of how to do it. That means, let's say we want to do this. It would be nice if everything would be 1, maybe 2 queries maximum, and you only receive the information that you want to display. So that's as few queries as possible. That's optimizing for read, and only the information you actually want to display. I think these are 2 main concepts we need to take into account for the architecture. And because all these fields are different, that sort of means that for every page we need to store it differently. I think that's if we want to optimize on read. So if you make one activity and change it, you have to store it in all these places. So this will be the teacher activity collection. This will be the status activity collections. This will be the work page collections, and this will be the teasers. No, path teasers collections. I'm not sure how to call this. And this will be the activity collection. And you still also have like these edit pages. This is the view page, but you also have like an edit page. I'll try to make it like comprehensive, that we have all the pages. Edit activity page. And you can sort of have this form. I can just copy paste it. So all this information. So that's the learning goal. And here are also these battles included, so the goal battles. That's sort of important one, because I have to figure it out. And this is the edit, and maybe also like a history page, like we have for the learning goals, where you see the revision. All revisions. So that will be the history activity page. That, I imagine that will be, maybe it will be a bit similar to this status page, where we see all the messages as well. But I think we also would need a page with just revisions, so all the changes. This will be like the link to div, and then the date, maybe some time ago. And then yeah, we could do the offer maybe, but I don't think we need it for the activities, because only the teacher can edit the activities. So it will be the same person every time, or the same account at least. And the idea is that you could maybe give access to the account to multiple people. That's okay. Yeah, we don't have like a discuss page. That's this. This page is the discussion place to create comments, replies, discuss the changes. Yeah, so I think this will be enough if we support these pages. Yeah, all revisions for activity. Maybe we also want to, what about the revisions for the linked learning goal? That will be also useful to show on this page. So how it works, we have these learning goals, we have these activities, and they are linked together. And this can change by the teacher, the activity, but this can also change. This is the activity. They will have some changes. The learning goal can also be updated. And that's the learning goal. And this is by the community, and this is by the teachers. So, yeah. That's sort of the deal. Second. Okay. So we have all these pages that we want to support, and normally you would in normal schema SQL land, you'll just make one activity, put the data there, but and then just query it. That's not the way of doing it with NoSQL. So for this feature, for these activities, everything is sort of linked to each other. And it's quite difficult to do this with all these separate collections. So it's good to think about it. We're not really that expert in Firestore yet. So it's good to see how we can do this, basically. Collections, teacher activity collections, every page different information. And this is pretty great. If we have it, then it's great, because it's one query, you get all the information you want to display. So the end result should be nice, at least for reading. But for writing, it will be sort of a pain. So writing will be painful. So what if we change like an activity? We have to change it. Let's say we change the title. Let's say change the title. What will we need to change? We need to change this page, this information. So here we'll show the title. We need to change this, because here we change the title. The work page collection, we definitely need to change the info, and we need to show the revision, old title, new title, painful. The path, so every teaser that we have, we should change that, so the teasers will be up to date. This might not be that, we might not need to change it, because the algorithm will update these teasers quite often. So the new title will be used quite quickly. So this is maybe not that important to change. It can still use the old title first, and then after a while all the old things will be gone. Still better to change it if we can. Activity collection, yeah, title needs to be changed. Definitely. So to view, this is the show or conduct or the show activity page. I think we call it show. And this is then the edit page. And here we don't need to change the, it's not like a separate collection, but we need to don't do, this is just a edit page, so we don't need to really show something, just get like the latest info. And now we have the history page, and we need to add like a new revision. So quite a few steps. We need to, on right, we need to do 1, 2, 3, 4, 5, 6 steps. 6. If we change the title in this current architecture, we need to change 6 collections. So this is something to be aware of, and this is sort of the NoSQL trade-off we make. So it is a decision, and I think this is valid if we optimize on read. We can sort of take a look at what they say. Firestore optimize on read. Best practices. This is Firestore, yeah, okay. Let's read this document. Maybe there's something we forgot. Quick references when building an application for Firestore. Yeah, okay. That's pretty difficult because you don't support Europe, I think. Avoid the document IDs and ... Okay, so you shouldn't add like dots in your IDs. Do not use monotonically increase documents IDs. Yeah, don't use increments. What a word. Monotonically. How do you pronounce this? Pronunciation. How to say it? Give to us.
Monotonically.
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 I think I don't get it, but it's okay. Monotonically. Increasing documents ID. Yeah, it's a nice word. It's a bit strange, you know. Monotonically. Such sequential IDs can lead to hotspots that impact latency. Yeah, okay. So avoid using too many indexes. Okay. Be aware that indexing fields that monotonically increases value, such as timestamps, can lead to hotspots. What are these hotspots? Okay. Well, we can figure it out later if it gets in this document. So, be aware. Whoa, timer is already up. Wow. There's no interaction, no one's here. So let's just continue with this new timer. Avoid using too many indexes. An excessive number of indexes can increase write latency and increases storage cost for index entries. Avoid using too many. Yeah, okay, yeah. We did read this. You can let automate indexing. Read and write. Avoid writing to a document more than once per second. Okay. Use asynchronous calls where available. Yeah, okay. So just for your interaction, don't wait for things if you don't have to. Most of the times we want to wait, actually, because we'll show like the results. Offsets. Yeah, this is for list, I think. Yeah. If you want to do pagination, for example, you can sort of use cursors instead of offsets. That's better. Yeah, so it will retry transactions if they fail. For example, the internet connection is down or something. It will still continue like a few tries. For the best snapshot listener performance, keep your documents small and control the read rate of your clients. The following recommendations provide guidelines for maximizing performance. Exceeding these recommendations can result in increased notification latency. I don't think I have any snapshot listener. Yeah, okay. Understand the Cloud Firestore standard limits. Yeah, it should be plenty for us, but yeah, you never know. Yeah, there's some limits, like 2000 Cloud Firestore events. That's per second. That's quite a lot of events. I don't think we'll handle that. Maybe if we do all these event-driven things, but we have quite a few already, but yeah. I just want to sort of get an up-to-date feeling of this Firestore best practices. Avoid high read or write rates to lexicon from closed documents or hotspotting. We don't do this. The monotonically thingies. Scalar algorithm. You should not encounter hotspotting on writes if you create it. Yeah, so we sort of have this prevented by using this add method instead of set. It's not item potency thingy. So that's a little bit of the issue with add, that you cannot really get a consistent result, but there's an issue that you could create, for example, two of the same, but then with different IDs. That's something we might want to fix if that will become an issue. Currently we use this disable button, so you can only click it once. That's our fix for it now. Creates new documents at a high rate in a collection with few documents. No, that's pretty interesting limitation. So if there's a lot of documents, then it's no issue, but if there's only a few documents, then it could be an issue if you create a lot of them. Yeah, okay, don't do this monotonically. That's sort of the thing we get from this. Delete documents in a collection at a very high rate. Write to the database very high rate, gradually increasing traffic. So yeah, what I'm feeling about this, if you want to scale, you shouldn't really bulk up all the operations and do them at once. If it suddenly scales, and it can grow, but it should grow a little bit predictable for... so they have some algorithm to scale up these machines. If you are too fast with increasing the traffic rate, for example, it could be an issue. 500 operations per second. So that's ramping up traffic, sort of prepared like this. But yeah, one collection support. So yeah, if you migrate, this could be an issue. Then you can do it like this. But for real user traffic, we don't control this. If they make a lot of learning goals and other things, then we cannot really control it. That's fine. I think for real user traffic, this is not an issue. Yeah, okay. So I don't see anything about optimizing for read. Maybe there was this YouTube video. Cursors, yeah, that's this pagination. Yeah, maybe we should watch this video. I'm not sure if we can on stream, but there's this video, and I think he explained it quite well. Let's see, take a look.
So, what is Cloud Firestore? Why, it is a horizontally scaling NoSQL document database in the cloud. Oh, I guess we're done here. Well, that was easy. Other entry in that other table. For example, let's say I'm creating a database for a restaurant review site. I might have one from the different tables and joining them together, not you.
I'll just try to get like to the good parts.
Out. And my database doesn't care that one object has like a tandem jump.
Yeah, so this is pretty one of the cool things about this NoSQL, that if you have this collection, you can sort of add just random fields to it if you need to.
Data you're getting is really what you're expecting and fail nicely. With some careful querying, I could fetch all reviews for an individual restaurant, but I typically can't do both of these requests in one single call. But for a restaurant review app, this is probably fine, right? Like a user's first going to want to view a summary of like 20 or 30 restaurants and then drill down into one of these to see more details. And it's really only at this point that I'd want to request these extra reviews. So far not too bad. But what if we want to show the reviewer's name and profile picture in those reviews? This is where it gets a little tricky. Let's assume our users are represented by their own objects elsewhere within the database. And while I could add references to these users from within my review objects, there's still no way for the database to automatically grab like that user's name and profile for each review as I'm requesting them.
Yeah, so this is a good example, because this user database and then what it says, you just need to...
I would need to make a separate database request for every single review I get to fetch this information.
Yeah, so if you don't store it in the review collection itself, you have to retrieve that information.
And that's bad. So if we want to automatically include some information about who wrote a particular review, we'd most likely need to copy some of that user profile data, the author's name and picture, for instance, and place it into our review object.
So you're copying data from one place to the other place.
Now, if you're coming...
In our case, that would be copying, for example, this title of the activities. We have to copy it. So we have to copy it 6 times, and not else every time you have to do a query when you want to show the page.
Coming from a traditional relational database world, you're probably freaking out right now, right? You're like, what are you doing? You're gonna have like duplicate data all over your database, and that's like the worst thing ever to happen in programming since goto statements. And you know, you're kind of right. People who have spent their time with relational databases have been taught that data normalization, meaning that every piece of data should only exist in one place in your database, is super important. And they kind of got a point. Like in a situation like this, it would be a lot more work if my user decided to change their profile picture. I need to look up every review where I've copied over this profile picture information and replace it with a new one. And there's always a risk that I don't change it everywhere and suddenly I've got inconsistent data in my database. And so now maybe you're thinking, well, this just seems terrible. Why is it that NoSQL databases are so hot right now? Why are there so many developers moving away from this nice world of like clean tables and data normalization and join statements for this crazy new messy world of data storage? So yes, one of the big drawbacks of having this duplicate data is that when I change it, I have to change it in multiple locations. But on the other hand, anytime I want to grab a review, it's really freaking easy. Like all the data is right there for me all in one place. No need to run joins across multiple tables or anything like that. And while that means our writes are going to be more work, our database reads end up being really fast.
So yeah, reads are fast, writes are difficult.
And for many apps, if you really think about it, your reads are going to outnumber your writes by like a lot.
Yeah, so we have that as well. We have far more reads than writes.
I mean, how many times am I going to change my profile picture? Like once a year at most? But on the other hand, maybe a couple dozen people are going to see my restaurant review every day. So when it comes to this data here, our reads might outnumber our writes by like 7,000 to 1. And so maybe it makes sense to optimize the case that's going to happen 7,000 times.
Yeah. So the same for us, I think. Especially if these, maybe not if it's in active work, then there will be quite a few writes on this page, quite a few diffs. But especially if it's sort of published, then you still, this is, these theses will be read a lot, but this is sort of generated as well on every algorithm set. This once an activity is there, it will be there, and also this page, it's more reading it, see the changes than writing it. So I think it's valid for us to optimize for reads as well.
Over that case that's going to happen once a year. But I think the biggest advantage with a NoSQL database over traditional databases is that it's able to distribute its data across multiple machines pretty easily. And this is a big deal. With most relational databases, if my app gets super popular and I need my database to scale up to a larger and larger data set, I generally need to put it on bigger and beefier machines, and this is known as scaling vertically. On the other hand, with many NoSQL databases like Cloud Firestore, if I need to scale up to a larger and larger data set, my database can, behind the scenes and pretty much invisibly to me, distribute that data across several servers and everything just kind of works. And this is known as scaling horizontally. And for those of you who are working in managed server environments like the Google Cloud Platform or AWS, it's pretty easy for these systems to automatically add or remove servers to your database as needed with very little to no downtime. So your database can scale pretty much automatically without your ever needing to lift a finger. And it's really for these reasons that you're starting to see a lot more databases, particularly ones hosted in the cloud, moving to this NoSQL model. But now if you're...
Yeah, if we're honest, we could probably support like 10 million users for this platform with a normal database. So scaling might not be the biggest advantage that we have, but well, it doesn't hurt, right? That you don't have to refactor the whole code base. So yeah, we picked it already, but it's not like you cannot do scaling with SQL database. You can scale quite a bit. But it is for this cloud infrastructure, it's of course the way to go.
Coming from a NoSQL background, like the Firebase real-time database, not much of this is new. Well, maybe except for the automatically scaling part. Cloud Firestore does handle that a whole lot better than real-time database. But it's more than just that. So let's talk more specifically about Cloud Firestore's document collection model. In the real-time database world, we typically describe the data that's stored in Firebase as a big JSON tree because, well, that's basically what it is, right? It's a tree, it's got keys and values, and those values can sometimes be objects that contain other keys and values. Now,
yeah, we'll just go through the video a bit more because he will talk about collections now, and it's just good reminder for us to get a repetition. I'll also link the video, maybe the page in the chats.
Values. Now, Cloud Firestore, like the real-time database, is a collection of objects, and all these objects are stored in a tree-like hierarchical structure. And while databases like the Firebase real-time database store everything as a big old JSON object, Cloud Firestore is a little more organized in that it's made up of documents and collections. Now, documents are similar to JSON objects or dictionaries. They consist of key-value pairs, which are referred to as fields in Cloud Firestore land. And the values of these fields can be any number of things, from strings to numbers to binary data to smaller JSON-y looking objects, which the team likes to refer to as maps, among other things. And that's a document. Now, collections are basically, well, collections of documents. You can think of them like a hash or a dictionary where the values are always going to be some kind of document. Now, there are a few rules when it comes to using these things. The first is that collections can only contain documents, nothing else. No collections of strings or binary blobs or anything else here. Second, documents can only be 1 meg in size. Any larger than that, and you'll need to break it up. Third, a document cannot contain another document. Documents can point to subcollections, but not other documents directly. So it's very common to see a collection containing a bunch of documents, which then point to subcollections that contain other documents, and so on and so forth.
Users workouts history.
The fourth rule is that the very root of a Cloud Firestore tree can only contain collections. Now, in most real applications, this will seem very intuitive. You'll have like a users collection and a tasks collection and so on. I do find the one time this ends up being confusing is when you're building your first little tiny test app where you're storing like 2 pieces of data. Like it's a little weird to store hello world inside a document that's then inside a collection. But in most real world use cases, this will be fine. Trust me. So this means that as a general rule, you're going to be drilling down into your data by specifying a collection and then a document and then a collection and then a document and alternating like that until you get to the document containing the data you actually want. Since this code can get kind of messy and awkward, you'll often be specifying the document or collection you want by creating a path to that document. Kind of like this. Just remember that in your path, you're still going to be alternating between collection, document, and so on. So let's go back to thinking about our restaurant review app. It seems like a no-brainer that we're going to have a collection called restaurants. And each one of these documents will contain some information about the restaurant, as well as probably a pointer to a review subcollection. Now within this review subcollection, you're going to have a bunch of documents, and each document will represent one individual review. And so within these documents, you're going to have a pretty large text block containing the review itself, and then probably a few other details like the overall rating and the date and so on. And already I'm kind of digging this hierarchical structure, because it turns out to be pretty trivial to grab all the reviews related to a restaurant here. But then we're also going to want information about who wrote this review. Now I'm pretty sure our app will have some kind of users collection, but that'll probably be more of like a top-level collection that would contain all sorts of information about that user, like their name, their user profile, last login time, default location, food allergies, what have you. And this really does feel like a top-level object, not something I want to make as like a sub-collection of a review. And so I talked about this earlier, but this probably
So he talks about this feeling. It's a feeling that it's a top collection. So in our case, what do I am feeling? So we have this learning goal. That's definitely a top collection. It already is, but it's goals. I think we call it goals. And then we have a player. That's sort of the user information about the maps. That will be a top collection. Maybe a curriculum profile. That's sort of your profile if you want to edit the learning goals. I think that's a top collection. And then we have activities. I have a feeling that's also a top collection. Even though this link is one-on-one, it's my feeling. All feelings are valid. Oh, this is one. This is one. Every activity will have one learning goal now, and many, of course. Learning goal will have many activities. Let's continue.
It means that if we want to include information about the user who wrote this review, our review documents will probably contain a couple of fields, like author name and author profile picture, since that's probably the only user information I'm going to need when I'm looking at a review. And if I wanted, I could also make this a map field, those little JSON-y looking things, kind of like so. And so this would probably be duplicate data that would live both in the top-level user object and in this individual review. And we'll talk in future videos about the best strategies to keep these kind of things consistent. Incidentally, if you're coming from the Firebase real-time database land, this kind of deep nested structure might be giving you heart palpitations, because in the real-time database world, when you retrieve some element in the tree, you automatically retrieve everything below it. And that would mean downloading potentially hundreds of restaurant reviews anytime I want to grab like a couple dozen restaurant documents. But in Cloud Firestore world, queries are shallow by default, which means when you grab documents within a collection, you only grab those documents. You don't grab documents in any sub-collections. So I can go ahead and grab my 20 top-rated burrito restaurants and just get those restaurant documents without all the reviews associated with them. Which, kind of makes sense, right? I mean, if I'm doing a search in my mobile app for best burrito places, that results page is just going to contain that basic restaurant info. I don't need the individual reviews at this point. Later, if I were to click on one of those burrito places to get more info, that's when I want to see the individual reviews, and that's probably the point where it makes sense for my app to request them from the database. Make sense?
Yeah, I think he goes into it, but you can see like if you want to open a restaurant, you also want to get like some teasers or the first reviews. And where should that be? That should also then be in this collection.
All right, so I know there was a lot to go over, but let's summarize. Cloud Firestore is a NoSQL, horizontally scaling, document model database in the cloud. See? Just what I said at the beginning. All kind of makes sense now, right? Now, there's plenty more to talk about here, like how you can run queries in Cloud Firestore, tips for optimizing your data, and how to keep it all secure, all of which are great topics for future videos. And hey, lucky.
This is free. Where's the next one? Is this like the playlist? Yeah. Get to know how queries work. Yeah, I did watch this before, but that was some other thing that was pretty good. But this one, I think, how to structure your data. This is the playlist for people that also want to sort of see all the videos. Yeah, so this is restaurants. So let's do another video. I think it will be helpful. This is, I think, the last video, and then we'll design our own collections a bit better.
So as you recall from our last video, there are a number of rules governing how Cloud Firestore works that all play a part in how users structure
We'll do
data.
it in 2 times speed, and I will break when I want to say something.
Let's find to talk about these rules in theory. I think sometimes it's better if we can put these in the context of some real world or close to real world examples. So come on with me, let's figure out the best way to structure our data on this episode of Get to Know Cloud Firestore.
What did you say? Rule 1, documents have limits. You can't retrieve a partial document. Queries are shallow. Yeah, so you will return everything. Shallow, that means you cannot join, I think. You're built by the number of reads and writes. Okay, okay. Queries find documents in collections. Yeah, arrays are weird. Okay.
So come on with me, let's figure out the best way to structure our data on this episode of Get to Know Cloud Firestore.
Whoa, whoa, whoa.
So for the purposes of this video, let's keep pretending that I've got this great restaurant review app that I'm powering through Cloud Firestore. Maybe it's got a search page where you can like search for the top 20 Japanese restaurants in Boston, stuff like that. And from the search results screen, a user could click on a restaurant to see details about it. This detail screen would have more info about the restaurant, along with maybe a few snippets from its most recent reviews. We'd have an option for a user to see more reviews, and if they click on any of these review snippets, we would show them the full and complete review. So pretty standard. Let's tackle a few questions around how we want to store our data. For starters, where will we put the reviews? I mean, when I've used this example in previous videos, I've generally assumed we've had this kind of database design. We've got the restaurants in one collection, and all the reviews are in individual subcollections. But is this actually the right design? Let's look at a couple of alternatives. Alternative number one, let's not make these reviews separate documents. Like we can stick all the review data into the main restaurant document as a map or an array of maps. Once a user clicks on a restaurant, I could give them these little review snippets immediately because I've already got them loaded up. And hey, as a nice little side effect, I've also saved myself a bunch of document reads. So this is an alternative, but maybe not a very good one. One problem with keeping our reviews in a map field like this is that when a user decides to search for the top 20 Japanese restaurants in their city, we're not only grabbing all the information about the restaurant, but we're also grabbing every single review for every restaurant on that list. And that is a bunch of reviews and frankly a whole lot of data that they will probably never need. I'm also going to run into limits, either the 1 meg of data limit or the 20,000
Yeah.
field limit if these restaurants get too many reviews. I also can't query these reviews either, right? Like I can't filter for just the 10 most recent reviews or anything like that. I only get back my giant restaurant document with all the reviews in there, and if I want to sort those reviews or filter them or something, I would need to do that on the client. So I think keeping reviews in their own separate collection is the right way to go. But let's look at our second alternative, which is what if rather than keeping these reviews as a sub-collection for each restaurant, they were just in a completely separate top-level collection? Hey there, Todd from 2018. Todd from 2019 will handle this one. Now, this gets interesting. Your first impression might be, oh no, don't do that. It's going to be a lot harder to get reviews for a single restaurant. But that's not the case. Remember, queries in Cloud Firestore are always fast. So grabbing all reviews for Todd's Tacos from a collection of 3 million reviews takes essentially the same amount of time as just grabbing all the reviews from a single sub-collection.
Not sure if I get this. What is he saying? One sec. What is Todd from Future is
Remember,
saying?
queries in Cloud Firestore are always fast. So grabbing all reviews for Todd's Tacos from a collection of 3 million reviews takes essentially the same amount of time as just grabbing all the reviews from a single sub-collection.
Let's do that in normal speed. What is he saying?
That's not the case. Remember, handle this one. Now, this gets interesting. Your first impression might be, oh no, don't do that. It's going to be a lot harder to get reviews for a single restaurant. But that's not the case. Remember, queries in Cloud Firestore are always fast. So
Queries from Firestore are always fast. Okay.
grabbing all reviews for Todd's Tacos from a collection of 3 million reviews takes essentially the same amount of time as just grabbing all the reviews from a single sub-collection.
So this is quite important, maybe for us as well, because querying is always fast. That was not the impression I had before, to be honest. So, yeah, let's say these are from tacos and there are 3 million, and that's the same as having this sub-collection from taco and then the reviews.
I could also do things like search for all reviews by an individual.
Hey, El Papa Pig, welcome. We're just thinking of the architecture, and I'm recapping a bit how Firebase works, because it's been a long time that I watched these videos. We have all these pages that we want to show some data, so we have a bit of an idea of the app for these activities, and we're just thinking about how to store it in the backend in the Firestore. That's why we watch these videos from the Get to Know Cloud Firestore playlist. I just want to check it out. And I did
author without having to enable a collection group query.
What did he say? I think these details matter really. Like, if it doesn't matter, why not do a top collection?
Reviews by an individual author without having to enable a collection group query. On the other hand, some things are a little harder. Specifically, doing something like grabbing reviews for a restaurant sorted by date or sorted by score or sorted by most popular would require a composite index, whereas I wouldn't need that if these reviews were already in their own sub-collection. Also,
okay, so if you want to do some difficult sorting or querying, then you would need to have this composite index. But is that really an issue? We can just make indexes, right?
a number of security rules are probably easier to write when I'm dealing with sub-collections of a specific document instead of another top-level collection.
Okay. So to secure the app, it's also a bit easier if it's in sub-collections.
Mostly in cases where you're going to want to restrict access to a sub-collection based on what's in their parent document. So, like I said in the last video, if you really think most of your queries are going to be across all reviews and not by restaurant, go with a separate top-level collection. But if you think you're mostly going to be doing searches by sub-collection, keep them that way and add support for the collection group queries you know you're going to want to use. And so I think I'm going to go ahead and keep the structure here. Okay, Todd from 2018, I'm going to go ahead and keep support for the collection group query sub-collection, keep them that way and add support for the collection group queries you know you're going to want to use.
So you can still do like this group query. How is it called?
And so I think I'm going to go ahead and keep the structure
Yeah,
here.
yeah.
Group queries you know support for the collection group queries you know you're going to want to use. And so
Collection group queries. Let's Google that one. Collection group queries. I never really used them, so maybe that will be like a good way of doing some of this this thing. Okay, it's quite old. Should have seen this before, maybe. Let's take a read of this article. This is also from Todd Kerpelman, the same guy that explains these concepts in the videos. Collection group queries for Firestore. What are they and why do we care? In Firestore, your data is divided up into documents and collections. Yes. Documents often point to sub-collections